you know, something like this would be like a little buck supply for my main driver gate drivers, just to supply a little more power. But, you know, this is clearly not isolated. It's using a single winding, right? So this is just a normal buck converter topology. But I need something that's going to use an actual transformer, you know, to provide electric isolation. Now, to be clear, I've done this, you know, typically I've just connected it all together, right? You know, for testing, I'm not too worried about it. That's actually still how I've got that other one over there. I just kind of looked at it like, well, something happens, right? Even on my other smaller one, it's the same way. But in this one, like I say, since the bridge is pretty expensive, I'd rather not destroy something else with it. You just switching the IGBT over here off the same logic. I just want to go ahead and isolate that for good measure. But it's not like it was absolutely necessary for me to get this running without it exploding, right? All right, so I've got a UCC 27245, I think it is. Or no, UCC 27524P, right? Dual low side, non-inverting. And of course the TL494. And then I've got a couple IRF 3205s, right? 15 volt regulator. I'm going to use to power both of these ICs. Then I'm just going to run the drains off of the main 24 volt in. All right, so to set the frequency of the oscillator on here, I believe it's pins 5 and 6. I'm just using a like a 2.2 nanofarad cap, and I'm going to put a 10K pot in series with, I believe, about 6.8K. So I have to sort of scope that, but that'll just be like the first values. Because the TL494 right here has transistor outputs, can't really drive the inputs directly with that, right? So I'm basically going to take something like 5K resistors, put 5K pull-ups on each input to actually pull the inputs high instead of low. I'm not sure the value of these pull downs. They're probably like 100K or something like that weak. So I'm just going to pull each one high and then use the transistor outputs to, you know, switch them low. So 5K seems like a decent value. All right, and then I want these two outputs to run push-pull out of phase, right? So I want to take pin 14 Vref, which I believe is the 5 volt output reference, and I want to take pin 13, that's the control out. I want to run that into Vref, right? So if I put 13 high, it should be push-pull. If I ground it out, it should go single-ended in phase mode, right? All right, so here's going to be the transformer I'm going to try. I don't really think I got the secondary windings how I want them, but I don't really feel like recutting some wire and rewinding it. This is a center tap primary. There's something between 25 and 28 turns between the tap. And the secondary is, you know, I was trying to hit for somewhere between 30-40 turns. I didn't even really do napkin math or anything. I just kind of feel like it's kind of fun to just sort of build stuff like this as you go. I'm just sort of intuitively trying to ballpark stuff here, and then I'll just, you know, kind of see what happens after that. Maybe learn a lot in the process, right? So most of the power supplies I've ever made were pretty much, you know, inverters. And if I actually built some purpose-made supply, I would typically just buy a module, right? These DC to DC converters are kind of a thing where, you know, you're either going to find really legit small ones not meant for a lot of power that I'm sure you maybe could get by with for certain gate drives. But since I'm driving a really old, gigantic IGBT brick, I just want to make sure that, you know, I don't have something too puny, right? 1.5 amp linear regulator would seem to work fine in my opinion. It's just not isolated, right? So you can see the level of isolation I've got here. I'm not really too worried about it. I've wrapped the core with tape. That's the winding isolation that I'm gonna have, right? Just that little gap. To actually get the duty cycle to modulate around in order to create the proper output, then I'm gonna have to put that optocoupler feedback on the isolated side. Just gonna run that through one of these guys, little adjustable shunt regulator, precision shunt regulator. Just straight from the optocoupler back into the TL494, I'll be able to get a more precise reference voltage off that precision shunt, right? So then based on that, you sort of got all the basic components for an isolated DC to DC supply. So then the question is, you know, if I can actually get it sort of switching okay, how crappy is that output going to look, right? But again, the point is isolation. So in this case, again, I'm not too worried. I can just put an actual, linear regulator on the other side of it if I felt like it, right? I suppose now that I think about it, that could be one way to do it. There's probably a way to get this open loop, knowing you're pulling well under like 510 watts. I mean, you're talking about very small peaks driving the gates. the average power, the constant power is like so small. What's the big deal, right? So, I mean, technically, I probably could just run this open loop and just have it feeding a linear regulator, right? So in that regard, say I wanted to go that route, I would actually need to create a stable duty cycle with some fixed values on the TL494. If I create a stable duty cycle where I feel like, okay, I'm going to turn this thing up till I feel like I got maybe decent output, and I'm not saturating it, shouldn't be a problem again with such a small load. And that would really be it. Then I would just smooth the output, rectify it, and throw that linear regulator on there, have that power it directly. And then boom, I would use probably whatever that output is. In this case, it'd be 15 volts, run that straight out. So I wouldn't need the whole feedback network on the isolated side in that case. So when it comes to worrying about like, saturation or flux walk from some type of straight DC, that kind of gets into like design considerations, right? So while I'm not like some, power supply design guru or anything, I'm sitting here thinking about stuff like, well, it'd be nice to add some type of DC blocking. I'd probably take like a DC blocking, put it on the other side of this choke right here, and go straight to the center tap, right? But then it's like, well, I'm kind of ballparking around the 30-50 kilohertz operating region for this thing, and I would imagine that would need to be a fairly large capacitor. Let me put it this way. I would probably have to like stack a bunch of 10 microfarads or something like this, but I don't really have suitable caps for that. But if I was to increase the PWM frequency to like a megahertz or something, well then yeah, I could probably drop that cap down way smaller. Same thing with this guy. But then you start getting into like, well, I did throw this on a proto board. I don't really think that's the best idea, right? So it's kind of like, well, do I want to kind of play a game of how high I could possibly go with this thing before other problems come into play? Or do I want to play a game of kind of how reasonably low but above the audible I can run this thing to where I don't really need gigantic parts, And again, it's not really a huge deal in my case if I'm talking about a pretty low power supply, right? So kind of keep it simple. Don't need to make it crazy. I guess if I really wanted to, I could try to create a super awesome layout, but I'm not going to do that. So that's kind of the compromise I'm making. I'm not really going to add any DC blocking. I'm just going to hope everything plays nice. All right, so I forgot I had this junk power supply laying around. And then boom, there goes some optos. I believe I see 817 on there. So that should actually work fine. And I guess technically just could have taking one of those, right? I got the LED side over here, and then the transistor side is going to go towards the TL494 circuit because that needs to go back into the feedback. But here on the LED side, that's all I'm really worried about as far as this little feedback network. So I got my filtered voltage output from the transformer, so I'm just going to go ahead and run the V out into the anode through. I'm just going to use a 2.2K resistor. So if I'm planning to run like 15, maybe up to 24 volts out, I feel like that'll probably be all right. I'm just trying to limit the LED current, of course. I'm going to throw that on there. And then I guess what I'm going to do is I'm just going to jump the V negative over. But I'll remove that strap later to insert the TL431. That's basically just going to go on the low side in between over here on the cathode and the V out. And that's basically where I'm going to have to put my voltage divider to basically be able to adjust the output voltage, right? All right, for the opto, this is probably one of the most common 4-pin optos. Kind of got to find your dot. So this top right pin is going to be my collector, bottom right's emitter. I'm just going to run that top collector out to the feedback pin, and emitter to circuit ground. All right, and then as far as the the 431, you got a reference, anode, and cathode. So basically, coming in through this current limiting resistor into the anode, then I'm going to come out there into the cathode of the 431, then the anode's going to go over to ground, and then I'm going to have a reference pin, and that's what I'm going to put another like a 10K pot on or something to create a voltage divider to just feed the reference voltage in, which will let me theoretically adjust the output voltage in a way that I want. Alright, so with this basic kind of setup here where I'm kind of bootlegging it, I'm not real sure if this is going to work, but minus the shunt regulator, I'm just coming off this cathode through an extra little an extra little resistor. I'm still going to use this divider, try to see if it'll work. So I'm basically at the point now where I could try to test it. What I need to go ahead and do is get the dead time set on this chip. So pin 4 controls the dead time, which could be useful for trying to make sure your output, your push-pull is going right. So instead of just grounding that out, what I'm going to do is try to feed it it's controlled by a certain reference voltage. So I'm going to try to feed it a good voltage, something like 0.5 volt. I'm going to run a couple resistors, one from Vref, and then the other one from ground into this pin 4 right here. So hopefully I won't have to change that later, right? All right, so from the 5 volt pin 14 reference, I got an 18K going to the pin 4. Then from pin 4 going to ground, I got a 2.2K. And then I'm just going to throw like a little 1 or 10 nanofarad capacitor across pin 4 to ground, just so that doesn't sort of walk around. All right, so I got it set up to sort of test. It's got a voltmeter on the output and this 12 volt fan. Now I did notice I did wire this wrong actually at first. Just a simple error on the oscillator portion. For some reason I ran the pin 6 over to Vref instead of ground. So anyway, I just switched that over, and now I can turn this on, see my squares. So I mean, I'm actually CC'd right now, pretty low. All right, so I'm just kind of limiting it that way. It's not really giving me any control on the output with this divider here, right? All I can do is adjust the frequency as of right now, and actually, so it's set. Go a little bit too low, but I can bring it up to about 50 kilohertz or so. That seems about right. But again, I guess this feedback I've got going on here is just not going to work. So as it is, this thing's going to want to put out a little bit higher of a output voltage than the input voltage. So it's only 8 volts right now. So I guess for some reason I hadn't even thought about it, right? But when I was looking at it, I'm sitting there thinking like, oh, I'm looking at inverted waveforms for some reason, right? So I hooked up both gates and I saw that I'm looking at literally like a 68% on time for each gate, and something in my brain was just like, oh, they're inverted. But then I thought about it and I was like, well, no, they're not, because I'm reading the gates. So then I remembered, oh yeah, okay, so what I did was pulled the inputs high on this low side non-inverting driver in order to switch them low with the transistor outputs of this TL494, right? So basically what I've got going on now is a crazy high reversed dead time, right? So I do have a lot of overlap, and that's the result of that, right? So basically I can kind of look at that and see, well, I can still sort of see, oh, well, the dead time, once I do reverse that around, I guess that'll be about what I want, right? I'm not quite sure how this thing's going to run like that, but it is kind of funny that when I turn this thing on with that much overlap, I mean, I can't really tell. It looks like it's really trying to chug the current out. The switches weren't getting hot, wasn't really high power, but at the same time, I had it CC, so everything on here was just barely chugging, right? But it's still going. All right, so now this is the part where, because of the little logic goof, I'll have to invert the logic on this some type of way, right? Because, again, this is a non-inverting driver, and I've basically made it so it's active low. I'm going to need to invert that, I thought about just saying screw it, and it's like, well, look, I'll just throw a freaking hex inverter on there. I don't really have room, so I'm just gonna have to modify it a little bit and then throw in a couple BJTs, right? And the funny thing about that is like, well, if I'm gonna do all that, I don't even need the freaking gate driver, right? I guess I figure, you know, with the same concept of like, well, I could add a Schmidt trigger hex inverter, you know, clean it up a little bit. Well, that's what the gate driver is gonna do. So I guess it, you know, either way, it's gonna be a little better than just your basic using these guys. But it's just, I don't know, it's kind of funny how that worked out. So if I had a different gate driving IC, I wouldn't have that problem. All right, this is sort of a halfway drawn setup, but so you can kind of see how the logic is going now. It's starting to get a little funky, but more or less what I had before was this minus this little totem here. So I'm trying to switch the logic inputs here of this UCC gate driver, this dual driver, with collector outputs, which isn't going to work unless I add these pull-ups here, which more or less inverts the logic. So since that was a problem, which basically means my dead time adjustment becomes inverted and practically useless, then I have to invert it again. So now you can see that's what these BJT stages are doing. So it's basically the same thing now, except now in this state with no oscillation in power, I'm just always loading these 5Ks down through the ground because hopefully these are always going to stay on, which of course they're not right now because the way this is drawn, nothing would happen because I'm where I started without these pull-ups and just the TL494. So I can't switch the bases with just a collector output, right? So now I basically just have to pull the bases up on here again. So these are always going to be on, and this is always going to be pulled to ground. So the switches are always going to be held low more or less until oscillation. So through all that jump hooping, now it's inverted back to the proper logic. I just need to bias the bases on these BJTs now so that the collector outputs here switch those. Alright, so now with that set up, with it still CC'd, and sure enough, I actually get better switching. It's not overlapping anymore. You see there's a whole lot of dead time, or just very low duty cycle. It's hard to say. I don't have a duty cycle set because I don't have feedback as of yet. It's just sort of kind of based on whatever the hell that opto, you know, ends up resting at, the LED bias or whatever. But you know, fairly low power, but I still got my switching frequency, so that's cool, and it's pulling way less, obviously. So now I can actually put in maybe my 24 volts that I want, but it's just like barely chugging. This is 15 volt regulated, so I should have a 15 volt gate drive. So yeah, aside from the duty cycle, that's about right. So bring it all the way to 24 volts. Hell, I almost got 12 volts out. That's not bad. Running that guy. So again, that's not really the end all. I still need regulation. I think that's pretty cool. I'm glad that kind of worked out. Just curious, let me check the ripple. All right, I'm just gonna sloppily probe this meter output here. Cut it back up at 24. So yeah, ripple's pretty bad. You know, again, not quite sure how that might improve. I'm sure it probably will to some degree once I get the TL431 again, right? But you know, whatever. Nothing crazy. At least it's a somewhat of a solid DC. You know, would that be too big of a problem? Nah, I don't think so. I don't know, see if something heats up. So far, it kind of seems like it might be all right, but there's clearly some losses going on here that will be a problem, probably at higher power, but I'm probably not even really pushing anywhere near that much when I'm typically going to run this how I plan on running it, right? So, I don't know, we'll see. I guess I could change the frequency. Yeah, so when I drop the frequency, that voltage picks up quite a bit. I don't want to drop it too low. Well, about 7 watts. Anyway, this is set for 50 kilohertz right now, or thereabouts. All right, so we saw this thing's pulling about 4 watts, 170 milliamps at 24 volts. So now I've just removed the only closest thing to a load on there, and now I've just got the voltmeter. And again, this is open loop. I'm hoping that thing don't shoot way up in voltage. It actually was. Let me start it lower. So about 16, okay, 18 volts. Yeah, we might be all right. So at 24 volts in again, I'm getting about 30 volts out, 28 volts out. But yeah, it's dropped quite a bit. So I'm only pulling 50 milliamps now. And I don't know, that might be about right as far as these resistor loads that I've got. The ICs are probably barely pulling anything, so I don't know, that might be all right. So perhaps I'm not dealing with like a huge magnetizing issue on that deal, and it just has to do with crap switching, right? All right, so now that I know that it's not switching too great, although it is operating technically how it should, these these switches are basically avalanching under load. No load, it looks all right, but they're still pretty lossy, as can be seen in the inefficiency, right? But then loaded, those drains start peaking up to like 80 volts, right? So they're clearly avalanching. That ain't gonna work. So short of trying to resolve, whatever in the transformer winding and things like that, now I just figure I need to go ahead and clean up the input side and all that stuff. So maybe snub a little bit of the switching. What I'm going to start with here is I'm going to try to snub the primary, basically drain to drain here. If that doesn't seem to do the job, at least now, what I can also try to do is just clamp the drains. So I might not need to do that. Maybe I could. I've also got some 33 volt TVS diodes that, again, that might also work. But now I'm just going to sort of see what it looks like switching after adding that. And the fact that I could see such bad switching peaks in the drains, it's like, well, boom, there you go. You automatically have to do something about that. All right, so while I did try to stack some, I think I put about 50 microfarad or something of these caps just to try them out. For whatever reason, they're not suitable for this, or maybe I just need a much higher value, but that basically just causes the oscillation to fizzle out within the first instance. So I just went ahead and removed those. Don't have any flux walk correction or anything like that now. I'm just gonna see what happens. And again, now it's oscillating. Of course, now the problem is this little snubber guy right here that I added across the primary has just made it worse. I just put a couple random values, I think 2.2 and maybe 22 ohm or something. So that ended up making it worse. So I need to change those values around. All right, so I've changed the snubber out. It's interesting, before my unloaded voltage, wasn't too crazy high. The drain waveforms were not really ringing or peaking very high. They looked fairly normal, but there were a bunch of little artifacts in them, right? After adding, I believe it was a 2.2 nanofarad and a 22 ohm snubber, basically just across the primary winding on the switching nodes, basically, the drain waveform got really bad, and then the spikes it was just horrible. So then I switched it out to 1 nanofarad and 47 ohm snubber across the primary, just to kind of show. So I'm putting 15 volts in. So that's what the drain waveform looks like now. So it's still horrible, but that's actually much better than it was. So now I can see I've just got this real bad ringing peak that's taking forever to fizzle out, right? All right, so I realized trying to hard clamp the drains to VN using some diodes, like some UF diodes, well, that wasn't a good idea, because I guess in the standard push-pull topology, the drains actually need to swing a good deal above VN, right? So I guess in that regard, I've got 55 volt FETs and I'm trying to run at 24 volts in, right? So that's kind of pushing it like right on the edge. But again, I've seen many times before that, you can avalanche these babies forever. I do that a lot on some small Tesla coils, I'm letting the drain swing up to 75 or more on some of them that I don't run for very long, and I've got heat sinked with a fan and stuff. But since I don't have these heat sinked, I'd rather not have them really avalanche. So I guess now what I'm saying is I'm hoping maybe I can play around with a bunch of snubbers and just barely have that healthily running at low power without worrying about them getting hot, because they are ringing like crazy, right? So basic values, something like 1 nanofarad, 22 ohms. All right, so I wasn't having luck using pin 3 for feedback. I'm not real sure why I went with that approach, but I think I saw it somewhere on a schematic and I thought I sort of understood it, so I was going to try it, right? It's not working for me. Maybe I'm almost there. I just need to shift some values around. But what I decided to do was just go straight into the air amp. So I'm using air amp 1. 2 is just grounded out. So now I'm taking the collector output from the opto and just running it straight to pin 2 right here. And I've also got pin 1, a 10K from pin 1 to Vref, and then pin 1 to ground through a 10K. But I've also got that going through this pot. So again, this ain't something I've really worked out a whole lot yet, but I found that having that on there brings up my max voltage adjustment range. So just sort of shifting the bias around, the level around, I'm able to do that. But, again, I'm not really 100% how that's working. I just know if I remove this little pot that I didn't really want in there before, then my max adjustment kind of wonks out. So now, instead of basically trying to pull up the pin 3 to put voltage on it and chop that up with the opto collector output, I'm basically just doing that with pin 2. And all else is basically going to be about the same, right? Except for these snubbers, again, I just want to go over. I was talking about clamping the drains to VN, which is not a good idea because VN needs to swing about twice as high, or the drains need to swing about twice as high as VN. Playing around with different snubbers. This one right here, I can't really say for sure if that's helped a whole lot. I added some directly across the drain source. Seemed to make it worse, so then I went back to basically now I removed this guy and then I just added a couple snubbers, basically drain to CT, or the center tat VN. So that still gives me some weird degree of adjustment here when I use that feedback, but I noticed that just with the values I've got, I can't really hit higher than 4 volts or so, but it does actually regulate. All right, so just to do 15 volts again, I'm just gonna power it up. And you can see I've got about 4 volts out. So it's really not pulling anything, which is better than what I had going on before. But you can see my adjustment has a very small window, right? And then if I sort of tune around with this extra pot I added, then you see all I've really got is just the ability to sort of drop that window down a little bit lower, right? But then at the same time, if I've got this 4.5 volts out, let's just say, and I just keep raising the input voltage, 24. So you could see it's not perfectly regulating, but it actually is regulating, which can be seen with the gate pulses, right? So again, theoretically, I guess you could get that to work, but now I'm going to add the TL431. All right, so now the 431 is wired in. I've just got it right there, so it's still on the high side. You see the anodes just going out to V out negative. The cathode's going straight to the cathode of the opto. I've just got my divider node here. All right, so I'm scoping the gate on one of them here. I'm going to start at about 15 again. And okay, so my pot is reversed now. I guess that makes sense. So I can actually, that's pretty cool. So with 15 volt in, at least unloaded output, I can bring it up to about 16.8. So maybe I can even, at 24 volts in, bring it almost about to a 1.1. So there goes the gate waveform. So you can see it looks like I've got a feedback loop going. And it's much, much better than what that opto was doing. That opto was doing some wild stuff on its own. That 12 or so should stay roughly about the same. And it is. So I'm gonna put it all the way to 24. Whoops. And let's see what we got here. So with this setup that I've got, this, you know, this random divider setup, I can bring it all the way down to about 8 volts from the 24. And let's see how high I can go. That's a 35 volt output cap. So okay, so 16 volts. I kind of wanted to get it a little bit higher than that, so I could probably tweak around with the air amp reference that I've got set right now to change that. So at this point, it's still about as crappily, if maybe it's a little bit more efficient than it was at 24 volts in, running that 11.4 out. Just gonna up that a little bit. So yeah, and it just starts pulling a little more power. Bring it all the way down. 8 volts. So I could tell there's still bad switching going on. I got 11 volts in. That's about 20 volts. So it's technically about right. It's just this super bad ringing right here is what I need to get rid of to help that efficiency a whole lot, right? Because that's just not going to fly. 55 volt FET. So again, that is the next problem, major problem, even though it is sort of working and regulating. Well, let's see, I gotta bring it up. Yeah, even though it is sort of working and regulating. So with 16 volt in right now, you can get about 14 or some out with pretty bad efficiency. All right, so I had added a little test bias pot over here before. Now I'm moving it back over here. So I basically just got, I'm just going to make it a rheostat. I'm only hooking up 2 wires. So the bottom here is just going to go to ground. And that wiper there, I need to find a good resistor value to run over to pin 1, error in 1. So I'm coming off pin 1 through a 10K, through this 10K pot, out to ground. And pin 1 also has a 10K over to Vref, pin 14. All right, so back at 15 volts again. Bring that up. So 15 in, it's pulling about the same. Let's see. And yeah, also already you could see I'm actually able to bring it up to 20 volts out unloaded at only 15 volts in, right? So that's actually a pretty big change. And I kind of wonder, so let's see, I'm going to bring that all the way to the top and bring the voltage up a little bit more. Oh yeah, so it's going up. So with 24 volts in, I'm not sure how high that thing's going to go. So again, I don't want it to go over about 30 or so. Okay, so you can see 24 volts in, about 40 milliamps, and I'm getting a max about 23.3 out unloaded, so that's pretty cool. So now I'm going to hook the fan back up to it and see what happens. All right, so fan connected, still 24. So it's still about the same efficiency as expected, but you know, my adjustment range has changed now. So I can actually 18 volts out and bring it up quite a bit, but I'm going to leave it at about the 12 volts for this load. And let's see, I'm going to bring it back, I'm going to bring the voltage back down to like 15. So as far as step down 15 to 12, that's not too bad actually. I mean, you know, it's still not super efficient, but it's way better than it was. And then, you know, once I go up to 24 volts, that's where it starts not looking too great and pulling a whole 4 watts. That load isn't really much over maybe 1.5 watts. So again, while the switching probably really sucks on here, I guess technically speaking, I could get away with the approximately 15 volts or so output in my case, I would make it about 18 because I'm going into some 15 volt regulators, right? Let's see, pull up resistors all seem to be doing all right. Diodes. Yeah, so while not incredibly efficient, I guess that'll work. Let me see what the output ripple looks like now. All right, so that's just on the output. Let's see, we got our 15 volts out still from the 24 volt in, so about 15. And I already know, it's not going to look too great. But as long as I don't see nothing crazy, I'm not really going to worry about it too much because, again, the linear regulator on the other end is going to do probably the most. So, again, yeah, about what it was, not too great. Maybe 500-600 peak to peak. So we're not talking about, again, anything amazing, but there's a lot of reasons for all that ripple. This supplies are not so easy, I would imagine. So I guess to give it a little more difficulty, I'll put a 24 volt load on it and see what happens at the 24 volt or thereabouts loaded output. So we'll just do 20 volts in. So I'll say that looked like that loaded it down quite a bit. Was I at 15 or 12? I can't remember. So I'm just going to put it back to 24 in. So pulling 7 watts. I'd imagine something might start getting hot on this thing now. Just out of curiosity. So yeah, about 12 right there. Alright. I wonder what happens if I change the frequency a little. Not a whole lot. So with the same setting, then this is not letting me load it down a whole lot, but I really don't need more than that for what I'm doing. So at the same setting, when I take the load back off, so with the load back off, still that's unloaded 24 volts, right? So there's a bunch of wonky stuff going on there. Still, this is not the easiest thing ever. We'll still need to tweak that, but technically that'd be a good enough. All right, for the power that I want. So it starts to struggle with something close to a 12 and a half watt load, but All right, so I would say I got a couple more things I need to do before thinking that I can just try to clean up the switching. It may be a smarter thing to do to just replace those 55 volt FETs with maybe some 100 volts, and maybe just sort of not worry about it. But what I'm going to do is I've got the dead time set right now. I would say it seems pretty low. It's kind of hard for me to tell just kind of looking on the scope. What I can try to do is take pin 4 and just ground it out, which should allow me, I guess that's the minimum dead time. I'm not sure if it just removes it altogether or just brings you down to the bare minimum. But that should make it so my on time should not really be limited anymore as much, I would imagine. Well, never mind. I already know that's not it because I already lifted it and forgot. So I just placed it back on just to see, and it did drop the power very slightly, but it wasn't that noticeable, right? So I guess that's not the problem. I can go ahead and put that back on there because that seemed reasonable. But something else is limiting the duty and the output power. And I don't really think it's totally in the losses, but I do know for a fact a huge part of that is that crap switching. So I guess what I'll do is maybe now that I know that I'm not limited by dead time, I am getting feedback, but the switching is super crap, and it seems like, I can't really get 10 watts out of it like I might want to, because at the very least, I want to be able to get 10 watts out of this damn thing. It's too big. I guess that's what I'll do. I'll go ahead and strap that back down to get a solid dead time, and then I'll see if I don't know, I can find what the actual problem is here.